Hello everyone. So I have the great pleasure of explaining homework number 15, homework problem 15 from homework number 3 to all of you. So the question asks, let A and B be non-zero integers and let C be an integer. Prove that the equation ax plus by equals c has an integer solution if and only if the greatest common divisor of A and B divides c. So, since this is a biconditional, as you could tell from the if and only if, we have to prove both ways of this theorem that we want to prove. So let's prove the first direction, that if ax plus by equals c has an integer solution, then the greatest common divisor of A and B divides c. So assume ax plus by equals c has an integer solution. That means c is a integer number and it's a valid linear combination of A and B. So since c is a linear combination of A and B, that means the greatest common divisor of A and B, which we will call D, just for simplicity's purpose, divides C. This comes from theorem 1.6.1 in the textbook, which is also on page 77, if you want to refer to that. That theorem pretty much states that the greatest common divisor of two numbers will divide any linear combination of those two numbers. So that proves that the greatest common divisor of A and B divides C. That's all we need to prove. So now we have to prove the other direction, that if the greatest common divisor of A and B divides C, then ax plus by equals c has an integer solution. So let's assume that the greatest common divisor of A and B divides c. That means c equals d times m for an integer m, which is non-zero, obviously. Now we can refer to theorem 1.8.1 from the textbook, which states that the greatest common divisor of A and B is the smallest possible linear combination of A and B. It's the smallest possible positive linear combination of A and B. That's important. So that means we can write D as AP plus BR equals D for some integers P and R, since the greatest common divisor is a linear combination. Now we can do some trickery here. We can do some trickery and multiply both sides by m. And this gets you APM plus BRM equals DM. Well, we know D times M is equal to C. And PM and RM are going to be integers, since they're both integers, and an integer times an integer is an integer. So we could just say PM equals X and RM equals Y. And what do you know? Lo and behold, we get AX plus BY equals C, which proves that part of the conditional, and it proves the whole entire theorem that we wanted to prove. All right, thank you, everyone.